Good morning, ladies and gentlemen. Hope you are sitting comfortably, have writing utensils out, ready to take notes. Please pause me as often as you need to. Have your notebook open to the current page as shown, and let's make a start. Okay, so we're looking at power laws for this lesson and for the next couple of lessons. And power laws are used to simplify complex expressions, both numerically and when using algebra. So here we have, what is it? An example where we have a to the 3, and just to remind you, a to the 3 is really like a times a times a. So what if we saw a to the 3 times a to the 2? Well, a to the 3, we've just said, is this. A to the 2 is this, and this multiplication sign drops down in between to form another multiplication here. And really, that's 5 a's in a row, so it's a to the power of 5. And that leads us to sort of discover our first rule, which is called the product law, where if we have the same base, meaning same letter or same number on the bottom, and we have a multiplier in the middle, we can add the exponents. So, for example, if we write 4 to the 3 and 4 to the 3 is a single power, that is 4 to the 6. Same here, 2 to the 6. Writing that in longhand, we could say that is 2 times 2, and this is 2 times 2 times 2 times 2. And then we notice that actually there are 6 2's together, so it's 2 to the power of 6. Alright, dividing powers. Next law is called the quotient law. These must have the same base. So here, if we wrote that out, there would be 8 4's on the top in expanded form. Dot, 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 over 2 4's. And you may remember with simplifying fractions, if we had common factors, meaning numbers that appeared in multipliers on both top and bottom, we can cancel them out. A 4 for a 4, a 4 for a 4. What that leaves us with is 6 4's on the top. 4, that's meant to be a 4. 4 to the power of 6. So we can, providing we have the same base, subtract the power when there's a division. So a to the m divided by a to the n, we do a subtraction in the powers. So this here, 3 to the 9 divided by 3 to the 3 is 3 to the 6. Here, 10 to the 4. Remember, we can also write that as 1 with 4 zeros. Here is 2 to the 3. Note that if we wrote 7 to the 5 over 7 to the 8, the result would be 7 to the minus 3. And it's entirely possible to have negative powers. That is fine. So, mixing it up a little bit, if we had something a little harder, please write this in as an additional example. If we had a to the 4, b to the 5, times c to the 2, a to the 4, over b to the 6, a to the 5, and we were asked to simplify that. Simplifying that, deal with the top first, bottom second, and then deal with the actual fraction. So if we're going to simplify the top, we might recognize that we have a pair of a terms, which will give us an a to the 8 on top, b to the 5, c to the 2. Traditionally, we write them in alphabetical order. Written like that, they don't need multiply signs between them. Over a to the 5, b to the 6. Then it's a matter of cancelling it out. We have 5 a's on the bottom, 8 on the top. We're left with 3 on the top, none on the bottom. It's like taking 5 lots of a on both top and bottom away. Here, we are left with b to the 1 on the bottom, and nothing touches the c, so it's c to the 2 on the top. So the neatest answer we could expect here is a to the 3, c to the 2 on b. And that would be as good as we could get. If you wanted to, you could write it like this: a to the 3, c to the 2 times negative b to the negative 1. You'll notice later on when we talk about we're at negative powers, b to the 1 down the bottom is the same as b to the negative 1 multiplied. Alright, thank you very much. Nice short video. Please come with these notes to class and we'll get into some maths.